Hello, my name is Dr. Preethi Vela Anandam. I am working as an assistant professor, the Department of EEE in SNS College of Engineering. Today, we are going to see a DC converters which is called as a buck converter. A buck converter is also known as a step-down converter. It's a type of DC to DC power converter which is used to convert a higher voltage DC input into a lower voltage DC output. It is widely used in the electronic circuit in various applications including the power supplies, battery chargers, voltage regulation, etc. Let's see how a buck converter works. So, we will be having a Vs input voltage and a switching element, inductor L, diode D, and the voltage across the will be having some capacitor and the output voltage. So, input voltage, the buck converter takes in a higher voltage input and typically operates in a switching mode. The input voltage is often referred to as Vin or Vs. And the switching element. The core component of a buck converter is a switching element. Often a transistor or a MOSFET switch we can use it. So MOSFET means metal oxide semiconductor field effect transistor. This element switches on and off rapidly to control the flow of the current through the circuit. And we had used the inductor L. The inductor L is connected in series with the load. The inductor stores the energy when the switching element is on and releases it when the element is off. This smoothens the output voltage as well as the current. And we can able to see the diode. A diode is connected in parallel to the load but in the opposite direction. It allows the current to flow when the switching element is off and prevents the reverse voltage from reaching the load. So, the freewheeling diode takes this action and the capacitor is used to remove the ripples present in the circuit. And we can see the output voltage which is called as a Vout. The voltage across the load resistor or the output terminal of the buck converter is the desired lower voltage output. So, the key principle behind the buck converter is that the pulse width modulation. So, by controlling the duty cycle, the ratio of the on time to the off time of the switching element, the output voltage can be regulated. The duty cycle is increased, the output voltage decreases and vice versa. This allows for the efficient voltage regulation. And also we know the advantages of buck converters. It includes the higher efficiency, smaller size and the reduced heat generation compared to the linear voltage regulators. They are commonly used in applications where the power efficiency is crucial, such as in portable electronic devices, voltage regulation power supplies and energy efficient lighting, etc. So it is a type of DC to DC converter. Let's see the operating principle of the buck converter. So in this figure it is clearly shown that along with the power electronics, a solid state device which acts as switch off circuit, there is a another switch circuit which is called as a freewheeling diode. So S1 and S2 we are having. So the LC filter is used to reduce the current or voltage ripples. So this helps in generating the regulated DC output. A resistor is connected across the pole arrangement which acts as the load for the circuit. So the full operation of this circuit takes place in two modes we can say. The first mode is the one when the power MOSFET S1 is closed. So here we can say S1 is open and S2 is closed. So in this mode of operation, say for example, a switch S1 is the closed condition, it allows the flow of the current to flow through it. Initially, when a fixed DC voltage is applied across the input terminal, then it is in the closed condition of switch S1, the current will flow in the circuit in this manner. So due to this flowing current, the inductor in this path stores some energy in the form of a magnetic field. Also, there is a capacitor in the circuit and the current flows to it also. Therefore, it will store the charge and the voltage across it will appear across the load. However, due to Lenz's law, the energy stored within the inductor will oppose the cause which has produced it, and so an induced current will get generated and the polarity across the inductor will get reversed. So we know that total time period will be that T on and T off. Okay. So here we can say when the switch S1 is open, the VL plus V out is equal to 0. So VL is equal to L into di by dt, which is equal to minus V out. The next one, we can see that the waveform representation. In the first condition, S1 is closed, whereas the second condition, S1 is open. So it is the waveform representation given in the circuit. Let's see it. So we can see that in the output voltage, the on period and off period is given to you. So V out is equal to D into Vs, where D is called as duty cycle T on divided by T off. We can see the on time as well as the off time in this waveform representation, and also the current across the diode and the current output current is everything shown in the waveform. So in this we can able to understand that the buck converters are used to provide a lower value of DC signal from a fixed DC input. So let's see, that is we have seen the buck converter. Buck converter means DC to DC converter. So my dear students, why is capacitor used in buck converter? Can you please let me know? And what type of converter is buck converter? So you please let me know, my dear students. And references, I have referred Alok Jain, Power Electronics and its Applications, and Mohammad Haj Rashid, Power Electronic Circuits, Devices and Applications. So thank you for watching.